Okay, so I guess we are live now. Just let me confirm. Or you can just write in the comments also that we are live. Just, yes, so we are live. So hello guys, we are back again with weekly contest discussion of Leetcode 487. We are going to send you a tutorial for all the four problems. I hope everyone able to solve at least three because today's contest was quite easy. Even the 6 pointer was quite easy. How many solves did you guys had? Hmm. Okay, nice. We will wait for 1 or 2 minutes, then we will start. Mhm. Okay, so let's start with the today's post contest discussion. And the first problem was count monobit integers. Okay, so in this problem, you are given with an integer n. An integer is called monobit if all the bits in its binary representation are the same. Return the count of the monobit integer in the range 0 to n inclusively. Okay, so this was an easy problem. Like you are given with an integer n and you need to count monobit integer between 0 to n inclusively. Okay, so what are monobit integers? Integer whose binary representation contains single bit. Okay. For example, 0 is a monobit integer because its binary is 0. 1 is a monobit integer because its binary is 1. 3 is a monobit integer because its binary is 1 1. Then 7 triple 1. Then 15 4 times 1 and so on. As you can see, the only bit 0 can occur in 0, and for rest it will always be 1 1 1 triple 1 4 times 1 5 times 1 and so on, and 0 can never come in this range again. So you can just directly see that this number is just 2 raised to power k minus 1. Yes or no? So just make to solve this problem. Yeah, all good. So to solve this problem, you just make a count starting from 1. Because why 1? Because we are taking 0 also. So for 0, I have counted as 1. Then just check, do a while loop and check till how much, till how many numbers which are in the form 2 raised to power k minus 1 is less than equals to n. Just increase your count there. Okay. So this is the logic for this problem. Okay. Let me just scroll it. Okay. So the logic of this problem is this only. Uh, It was question 1 and question 2. While question 2, 1 is contest. Yes, question 4. I fucked up in question 4 because I was a very minute mistake. I will show you what I did. Okay. So mm, this is the logic for this problem. Let's look at the code. As you can see, what I've done, I've made a count as 1, then k for 2 raised to power k. Then while your 2 raised to power k minus 1 is less than equals to n, just increase your count and increase your k value. Just that's it for this problem, and then return count. I guess this was an easy problem, everyone was able to solve it. Then we can just move towards the second one. Uh, Anyone who tried to solve this with maths, like I was not able to get a logarithmic formula. I thought it would there might be some logarithmic formula, but does anyone solve it with like maths in one line or one linear formula? Till then, we can just move towards the next problem. This problem is quite easy. In this problem, you are asked, you are given with an integer array nums solved in n log n time. Yeah, n log n time. It's okay. I was thinking like there might be some formula which you can represent the n in some logarithmic value so that you get an answer. I guess log n plus 1, I was thinking like that, but no, it was not working. Okay. So in this problem, you are given with an integer array nums. Two players, Alice and Bob, plays the game in turns, with Alice going first. And in each turn, the current player chooses an subarray nums L to R such that L minus R plus, which means the length of the subarray is less than M, where M is the current length of the array. Okay? So you cannot choose the current array as a subarray. I solved 3. No problem, Arpit. You can just look at the fourth one now. The selected subarray is removed. I use bitwise and check and with it. Yeah, first also one liner. What was that one liner? I was not able to make the formula in time, so I just thought, okay, just do it right now so that the rating don't go down. Okay, the selected subarray is removed and the remaining element are concatenated to form the new array. The game continues until only one element remains. Alice aims to maximize the final element while Bob aims to minimize. Assuming both plays optimally, return the value of the remaining element. Okay, Alice will go first, right? Here it was Alice playing first. If you know the one-liner solution for the first problem, please write in the comments so that I can also look at it. Oh, okay, so the second problem says that you are given with an array. Say this is my array. Okay, so and Alice wants when the operation is like you choose a subarray, you delete that. Okay, you can choose any subarray, but the whole array cannot be chosen at subarray. Okay, so these are our operations. Now, say Alice shows her this is subarray and delete it. Then the remaining the remaining array will be concatenated together. Okay, so this is your remaining subarray. Then Bob can choose some uh, subarray and delete it. At the end, the operation will continue until a single element is left. Okay, if this single element is left, you need to tell what element it will be, and Alice will try to maximize this, and Bob will try to minimize this. Right. Now, look at the problem. I can choose any subarray up to size length minus 1. Here length represent the array length, current array length. Okay, so I can choose any subarray up to size length minus 1. Let's take some example. Say this is my example, and Alice will go first. Alice know that 5 is the maximum element here. Log n 2 n plus 1. Oh, oh yes. This will. I was thinking about like log n plus one will work, but no, I just missed that. Uh, 2 raised to n plus 1 equals to 2. Okay, thank you, Arpan. Uh, okay, so let's take this example, and Alice will go first, and Alice know that 5 is the maximum element. So what she will try to remove the whole uh, array on the left or right of 5. Then the remaining element is 5, and Bob cannot reduce it anymore. Then the Alice wins because the maximum element is 5. Okay, now let's take another example. This time 5 is not on the edge. Let's say 5 is on a center element. Now, Alice knows that 5 is in the mid. Okay. And Alice also knows Bob will try to minimize it. There is no operation for Alice so that she can secure 5. Why? If she try to remove this array, the remaining array will be 5, 2, 3, 4. If she try to remove this array, the remaining array will be 1, 5. Okay. Then Bob has an operation at least because you are deleting from mid. There might be at least one element on left and one element on right. There will be one element on left and one element on right, and the single element here it will be count. So at the length of the array after ls operation will be at least be 2. Okay, if the length is at least 2, then Bob can easily delete this particular largest element. Okay, every single time. So the remaining values that are left for Alice is always the corner points, because Bob can delete the maximum element if it is in the center. Look, if the maximum element is on the edges, then Alice can just delete the remaining array like this or like this. Okay? Then Alice will have the maximum element. But if it is in the middle, then no operation can save Alice, because if it is in the mid, then Alice will try to delete some array. Like her best choice is to delete up to that maximum element and leave that like this is the max element, and delete this array, or you can delete this array also. So Alice's best option is to do this, and after that there will always be an array with length at least 2. Okay, so because of this, because the array will contain a length of at least 2, then Bob can delete the max element every time. Delete the max element every time. And while deleting, the only elements that are left, because if you choose to delete this, if Alice choose to delete left hand side of that max element, then the rightmost element is left. If Alice choose to delete the right hand side of the maximum element, then the leftmost element is left. Okay, so that's how you can just say the answer will always be either the first element or the last element. So you can just return the maximum of both of them. So this was the code, and the logic was this, that if it is in the corner, then Alice can remove the remaining whole array, and the last element that is left will be the maximum element. But if it is not in the corner, whatever she does, the array will contain at least array will contain the length of at least 2, and then Bob can delete that particular element, and the corner points will still left. Okay? As you can see, the code is just to return max of first and last element. Okay, so this was the logic over this code. I hope this was also easy to understand. Now we can move towards the third problem. Okay? right? So this is the third problem, and in this problem you are given with a design question, and a ride sharing system manages ride requests from riders and availabilities of from the drivers. Rider request rides, driver becomes available over time. The system should match the driver and riders in the order they arrive. Okay, so this is important. Now implement the ride sharing system class, where a ride sharing system initializes the system, which means it's the constructor, and after that you have a void rider function in which you add the new rider, the given rider ID. Now the next is void add driver function, which adds a new driver with the given driver ID. Next is your integer match driver with rider. It matches the earliest available driver with the earliest waiting rider and removes both of them from the system. Returns an integer of array of size 2 where result is equal to driver ID and rider ID. If a match is made, if no match is made available, then return -1 -1. Then void cancel rider. Okay, so the rider can also cancel the ride request of the rider with the given rider ID if it exists in the system has not been yet matched. Okay, so this was the problem. Okay, so question number 3. Now, just if you look at the problem is first come first serve. Okay, first come first serve problem it is. Why? Because the earliest rider with will always be matched with the earliest driver or the earliest most available driver. This most available driver. That's why it's first come first serve. So which driver gets the most early slot, he will get the rider. Okay. Now, if it is first come first serve, I can use a queue to maintain the things, right? I can use a queue in which I will put all the drivers D1, D2, D3, and so on. And with the queue front, I can just take out the driver and then push it back in the back. Okay, when it got available again. All right. So this is how driver will work. But for rider, I can't do a queue. Why? I can do like rider one, rider two, rider three. Look, I can do a queue if there was not this function, which is void cancel rider. If cancel rider function was not there, I can just directly implement two queues, take front of both of them, and just return that. Okay. But in this scenario, I have a cancel function, which means a rider can cancel from anywhere in between this array. Say the queue contains some R1, R2, and up to R2 power 1000. Okay? Now, if R50 thinks that he wants to cancel a ride, then I have to remove R50 from this scenario, and the whole system of R51 to R1000 will come one place ahead, and this will cost big of n. Sorry, it might be not visible. So this will cost big of n, right? Now, if this cost big of n, what I can do? Okay, so many of you have done this using vector and marking them as -1 or just false if the rider is cancelled the ride. Okay, but originally what Leetcode thought while making this problem, that you have to implement this riders thing not with queue, not with array vector. They thought you have to implement it using a linked list. Okay. So originally the solution must be in the linked list, so that, which means for interview, if you encounter this type of problems, you should use a linked list, but we were in the contest, so we can just use a vector and queue. Okay, so how I did is I have made a vector for riders and a map to map each rider which is inside my current imaginary queue. Okay, so I thought this is my imaginary queue, and I will map my rider with their rider IDs. Okay, and with their timestamp so that I can just remove them in big O of one operation. Now just put all the riders here. Okay, so and also map them with their ID. So map R1 with whatever index it is. So okay, so this is how you just do, and I am imagining it is working like a queue. You can use DQ also. Now, but the best approach must be linked list. You have to, because in the linked list you can just remove a node in big O one operation, right? Yes, because it's the best approach for this problem, but I don't want to implement the whole class of linked list first, then just right. It's quite complicated to write a linked list. Okay, so now how this thing will work for drivers? It is easy. Just pop out from the front of queue. Okay, for riders, I have an array. So I will have to make a pointer which will point to the rider. Okay, which rider is currently standing in the front of you. So if rider 1 is standing, so my pointer will point to rider 1 and d1. So I can just pair both of them. So it will be d1 r1 and remove this and mark this as -1. Okay. After this will be marked as -1. Now imagine r5 thought I want to cancel that, right? So I will mark r5 as -1 again here and remove it from my map. Great. Okay. Then your start pointer will always increment one by one, and when it encounter a -1 it will just skip it. Okay, so that's how you can just implement this problem. If we look at the code, it's quite easy to implement. There's not a lot of things here. So a queue for drivers, a vector for riders, and map to maintain their positions, rider positions. Okay. Now a start pointer to point on each rider. Okay, now, if you are asked to add a rider, just add the rider in the map also and push it into the vector also. Okay. How I am mapping it? Because look, if these are riders R1, R2, R3, R4, R5, R6, I'm mapping them like 1, 2, 3, 4, 5, 6. How? If when R1 came, the size of the vector will be 1, so I will map them as 1. Okay, then when R2 came, the size of vector is 2, I'll map as 2. When R3 came, size of vector is 3, I will map as 3. Okay, so this is how it is working. It is zero based, so you can just write zero based also. You know the idea, okay? The idea is been here. So I am mapping them like that. Then I will push that rider ID at the end of the array. Okay. Now for driver, just push them into the queue. It's quite easy. Now match driver with the rider. Okay. Okay, now look at this. While your start pointer is less than the size of the array, QS. mm, oh, questions. Okay, I will tell you at the end. Let me discuss first. Okay, so I will make my index when till the index is less than n. So this is basic. And if your index is -1, okay. So current what is saying that you are trying to map a driver. Okay, so I have an empty driver, let's say dx, and my pointer is currently pointing here, and it has -1, -1, -1 because all these rides are cancelled. Then you have a rider 7 here. Okay. Now, if these rides are cancelled, you need to skip them. That's why I am working on a while loop where your index is less than n and your rider is -1. Okay, which means you have cancelled, right? So just increase your pointer, go to up to the next available rider. Okay, so this is what it is. Now if queue is empty and your start pointer gets to the end value, either of them, which means your driver is not available and your rider is not available, either of them is true, then you just return -1 because it is asked us to return -1 if it is no match available. Now just take out the id from front of driver. It is driver id, so just write it here, driver id. Then just pop it out. Now take out the rider id from the array. Okay, now increment your pointer easy and erase that rider id from the map. Okay, now you have to return that driver id and rider id. So write it like this: for driver id and rider id you are asked to return. So this is how you can just implement match driver function. And your cancel rider function is, you need to check if that rider id exists in your map, which was my imaginary queue. Then take out that index, mark it as -1 and erase that. Okay? So this is your third problem. You can implement it like this. Why I'm checking here? Because sorry, this, because it is asked as if rider id exists, then only you have to remove, and has not matched yet. That's why I'm checking first in the map and then I'm doing. So this was the third problem. I hope it is clear to you. Now look, uh, for pattern observation, and if you are starting your TS, like how many solves do you have on Leetcode or Codeforces, like total problem solved? And if you're just starting, the best thing that you can do if you're starting your coding journey, the best thing that I have done was pattern printing. Use while loop to print patterns. Okay, just while loops. Okay, not for, because in for you know the formula to print any type of, like, make any type of pattern in your notebook and try to print it using while loop. A standard generalized printing. Okay, that's how you can just make your implementation string strong. And then coming to the logical like pattern observation, let me tell you one thing, like I am not very good on like observing a question. If I am encountering a new question, then I might get stuck for a very long time. But I've solved a lot of problems. That's why I have an idea from my past experience that how to solve a particular problem. If because something matches, like for the fourth problem here, when I looked at it, at this line, you can remove at most one element from the nums. Okay, so it takes me only half a second to know that it will use a prefix and suffix on min and max arrays we use. Okay, so I have solved a problem like that. That's why I know that if pattern if the question asked for removing at most one element and subarray something, so prefix and suffix will work there. Okay, so that's how you can just try to solve a lot of problems. Then you will get an idea how the things work for each of the problem. And while solving a problem, don't just do this like, okay, the problem come, I've solved it, throw it away. You need to memorize it for the later part. So in this kind of problem, the logic is like this. I hope you are able to understand what I mean. Okay. Now let's come to the fourth problem and the last. You are given with an integer array nums. A subarray nums L to R is alternating if one of the following condition holds. So alternating subarray, you know that sawtooth pattern, no, mountain pattern, mountain valley pattern. Okay, so I am not reading this. It is mountain valley pattern. Now, in other words, if we compare adjacent element in the subarray, then the comparison between alternate element must be strictly greater and strictly smaller. You can remove at most one element from the nums. Then you select an alternating subarray from the nums. Okay. Now you need to return an integer denoting the maximum length of the alternating subarray. You can select, okay. just subarray is it's telling what is the subarray, and length 1 subarray is always alternating. Now it's quite easy. Like if you know, if you are asked to make a subarray pattern like this, right? One is like this is A0, this is A1, this is A2, this is A3, A4, A5, A6, A7, A8, and A9. Okay. So either a pattern can look like this or a pattern can look like this, which means either you can start from top, okay, either you can start from bottom. Now, for both of them, you can make a prefix. You can make prefix 1 and prefix 2 to check both of them. Okay. If you are starting from top, what your idea will be that my current index, which is this, must be smaller than this. Okay. So you can just uh, say, so you will start from your I will be I minus 1 will be greater than your I. Okay. So in this manner, you can just make your prefix 1, and the opposite manner, you can just make your prefix 2. Okay. In which your I minus 1 is less than I. And while making prefix 1, prefix 2, what you have to take care of, just make prefix of I filled with 1. Okay. Completely filled with 1, because it might be possible that after some time the pattern will go constant or go increasing. Okay. If this happens, then this is not your good subarray. Okay. Okay. Wait. Okay. So as you can see, in this scenario, the best sawtooth pattern can be of size 1 only. Okay. Why? Because it is said size 1 subarray is also good. Okay. Now you can take this element, this element, this element, this element. So this will always make a sawtooth pattern, okay, of size 1. So that's why you have to fill your prefix with size 1 and your suffix with size prefix 2 also with 1. Okay. Now make a suffix also. Why I'm making a suffix? You can just make a prefix and check now what is the maximum length of this sawtooth pattern by prefix of n, right, or prefix of I at each time. No, because it is asked us to delete at most one element. So 4 is n 2 into 2 dp. Oh, you can use dp also. It is min-max dp. Oh, obviously, it's min-max dp problem. But look at my code; it's very clean. You know, I have solved these kind of problems a lot earlier, so I know an idea. So make a suffix also. Why? I am giving you an int, then if you are asked, like in an array, you need to delete any particular element. Okay? You are asked to delete any particular element, and then you are asked to either tell the maximum subarray sum, or either you are asked to tell you the maximum this pattern, length of the pattern, or sliding window, anything like that. Then always try to make a prefix and suffix, because if you're deleting this element, this part will be your calculated. This part will be calculated by prefix in big O 1. This part will be calculated by suffix in big O 1. Okay. Then you just iterate over all the elements from 0 to n. Correct. While iterating over all the values from 0 to n, just check your answer as maximum of your current answer, comma, prefix I minus 1 plus suffix I plus 1. Okay. Why this? Because I am deleting the ith array at the point. I am assuming I am deleting the ith array. So I can just take my answer as maximum of answer, comma, prefix I minus 1 and suffix I plus 1. Here I have two prefix and suffix, so I will do 2 times prefix 1 suffix 1 and prefix 2 suffix 2. Okay. So you know that why I'm doing this, because there are two kinds of pattern that can start from bottom, and either it can start from top. Okay, that's why I'm doing 2 prefix and 2 suffix. Right. So this is the logic of the code, and it's the most standard logic. If you are asked to delete a particular element from the mid part of any array, you can delete one element and concatenate it. So you have to make note that the the elements which is on the left hand side of that particular I is in the prefix, and the element which is on the right hand side of the I is suffix. Okay, so that's how I can just maintain both of them, and after concatenation the sum of both of them will be my answer. So if you look at the code, it's very easy. I have written very easy manner, like if n is less than equals to 1, you can just write an n or make an answer. Now I have made two prefixes in just one prefix. Divided is the length of the longest the element is up or down. Is where the element is moved. Yes, up or down thing. Look, I have made. You can do like that also with dpijk. Okay. So look, I made two prefixes in one vector only, vector of int. So it will contain both of my prefixes, where prefix I0 will tell me the up part and prefix I1 will tell me the lower part of it. So if you have num size greater than num size minus 1, so you will just append a single part with the previous one. Okay, why? Because you were coming from a lower index at that time. Look here, your prefix I is less than prefix I minus 1, correct? I minus 1 is less than I. So next time the I plus 1 must be greater on the greater side. Okay, so who was handling my greater side? It was prefix 2, correct? And my prefix 1 was handling the lower side, or vice versa. You can do any of them. Okay, so that's why while adding a prefix 1, I will do a prefix of I minus 1, which is of uh, which was alternating at that time. So 0, then 1. If it is was 1, then 0. Okay, take the 0. Okay, so you need to go for alternating pattern. So 0 and 1, and 1 and 0, and increment it one by one. Okay, this is what I mean by that sawtooth pattern. So if your num size greater than num size minus 1, just increment your prefix by 1. If num size less than num size minus 1, increment your second prefix by 1. Okay. Now take your answer as current. Take all the answer as maximum of answers for the whole prefix. Iterate for suffix again. Same thing. Make two suffix. Suffix 1 and suffix 2. If your num size is less than num size plus 1, increment your alternating suffix, and if your num size is greater than num size plus 1, alternating your increment your other alternating suffix. Okay, then take the answer. Okay, now I have told you the idea. What was the idea? I am iterating from 1 to n, and I am deleting at least one element. Okay, if I am deleting at least one element, so the remaining element will be concatenated. So if the pattern was nums I minus 1 was greater than nums I plus 1, then I will add the zeroth prefix, okay, with the zeroth suffix. Okay, if it is the other alternating pattern, then I can just add my first prefix with the first suffix. So this was the idea of this code. Is this clear, or anything which you were not able to get? Is there anything you were not able to get, or is this clear? Yeah, you can write in the comments. Just look at it and know that if it is clear or not. Not clear. Okay, so let me explain it again. Look, you were asked for the sawtooth pattern. So this is your pattern. Okay. Either pattern can start from top, go bottom, then top, go bottom. Okay, so it's either down, up, down, or you can start from down also. Either you can start down, up. Right? So this is your other pattern for the same array. Now I need to calculate any after deleting at least one element. I need to calculate the longest this sawtooth pattern. Okay, so to calculate after deleting it, you need to know that if you are asked to delete at least one element, and then you are asked to find maximum length, maximum sum, or any sliding window thing, or anything which is in subarray. Okay? Anything which is about subarray, you can directly use a prefix suffix approach. Okay, or min max tp, which is known as min max tp. Okay, so you start from front, make a prefix sum where it will store the longest pattern of longest zigzag pattern. Okay? So your prefix I will store longest longest min longest sawtooth pattern. Okay? And your suffix I will store your longest sawtooth pattern from back. Okay, why I'm making prefix and suffix? What is the idea of prefix and suffix? It's the idea is like, you know, you have an array, and if I ask you delete this element, okay, so I have deleted the ith element, and then you have concatenated the whole array. Okay, so this is your array. Now you were asked to find the maximum sawtooth pattern from here. So tell me, will you do a loop on this and then loop on this again? No. Why? Because I'm iterating on I, because I am deleting an I first. Then if I do another loop on array, on this new array, so it will cost me big of n square time complexity, right? So I need a way so that I, without calculating this sawtooth pattern again for each I deletion, I can just calculate in big O1. So is there any idea to calculate in big O1? Yes, because I am deleting only one element. So the element on the left hand side will not be affected, and element on the right hand side will not be affected. Okay. If I count from here, so the left hand side, right hand side will not be affected. If I count from here, the left hand side won't be affected. Okay. So what I need to do, I can just make for left hand side, I can make a prefix, and for the right hand side, I can make a suffix. Correct? Correct. Uh, Praneeth. Yeah. Is this clear? Can I do this clear? Yes. Okay. Now I can do this for one array. Okay. So it is one type of pattern that I can make a one prefix and one suffix. Now there is another pattern, right? Which start from down, up, down, up. So for that I need to make another prefix also, another prefix, another suffix. So let's call this prefix one, suffix one. And for that downward pattern, I will call them as prefix two as suffix two. Okay. Okay. Is this clear? For the both of the pattern, I can do something like that. make prefix 1 suffix 1 for first pattern, make prefix 2 suffix 2 for the second pattern. Now, if you have made them, how will you store your prefix ID? Okay, look, your prefix 1 will store like up to down, then your prefix 2 will store down to up. Okay, correct. Now, this is for the first index, like you are storing up to down and down to up for the first index. Now, if I ask for any index I, what you will do? You know that after this down and up must come. Okay, correct. After this down, up must come, and after this up, a down must come. Yes or no? If this is true, this is true, then look, for prefix 2, I am adding a down up condition from prefix 2 only because prefix 2 contains down up condition. But the up down condition was of prefix 1. Yes. So prefix 2 will contain prefix 1's condition of ith index plus 1. And here also, look, prefix 1 contains the up down condition of prefix 1. Okay. So prefix 1 is okay for up down condition. But as you encounter a down up condition, this is the condition for prefix 2 here, here, right? This is the condition of prefix 2. So I will do prefix 1 is equal to prefix 2 I plus 1. Okay. So this is why I am making my prefix 2 as prefix 1 I plus 1 and prefix 1 as prefix 2 I plus 1. Okay. Now rather than maintaining two prefixes, you can also make like this prefix of I and 0. This 0 defines your prefix 1 and prefix of I 1. This 1 will define your second prefix 2. You can do this. Then your condition will look like prefix of I. Now I have taken 0th prefix, which means first prefix. So I have to take second prefix in the addition, which was 1. So prefix I 1 plus 1. Now coming to prefix 2, which was 1. So it has the prefix 1 condition. Prefix 1 was 0. So I will write prefix of I 0 plus 1. Is this clear? I can write it like this or I can write it like this. You can do like this also. Just ignore this. You can write this also. This is also correct. Make 4 vector. Okay. No problem. So if this is correct, this is understandable. The suffix condition will also be same. Okay. Suffix I, suffix 1 will contain a condition of suffix 2I plus 1 and suffix 2 will contain suffix first condition I plus 1. Yes or no? Okay. So both of prefix and suffix condition are okay. Prefix and suffix are good. Now coming to the part where I am deleting a particular element. Okay. Now look, why I have to delete a particular element? If I have a sawtooth pattern, then it's all good. But I don't need to delete this particular element. But it might be a case where your pattern goes like this. This is your point, and it goes again, go down, or it can go straight. So this condition is not a sawtooth pattern condition. Okay. So that's why you need to delete this particular element, correct? Or delete this particular element. Which one you should delete? You tell me. If you are on a path where you have 3 elements, should you delete 0th, first or second element? All 3 of them are in consecutive decreasing or consecutively increasing order. So you must always try to delete the second element. Why? After that second element, it might be possible the up will come. Okay. If you delete the first element, just visualize it like this. Look, I have deleted the first element. So this will be deleted and your line will be straight. Okay. Now you can delete. if you delete this element, then it might be a problem. It might be possible that the element on the backend side of 0 was here, so it will get connected to here and it will still make a downward increasing pattern. We must delete an I or I plus 1 element. If we are standing on I here, so I minus 1, an I element will be considered. Okay, so I have to delete this element because there are either it is in total decreasing, total increasing, or constant value. So after I delete this element, okay, then your pattern might go straight, pattern might go increasing, or pattern might go decreasing. Correct. Now I need to know, just not let delete. I can write it here. Look. Now, if I'm deleting it, the particular peak or valley will be made after that deletion. So let's take an example. Look, I'm taking an example. This is 3 2 1 2 3 2 1. Okay. 2 1 2 3 3 2 1 2 3 2 1. Now, as you can see, 3 is on the top, then 2, then 1, then you go 2, then you go 3, then you go 2, then you go 1. Okay. So this is your pattern. Now, what you should delete here? What you should delete? This is 1, this is 2, this is 3. Okay. Look, in this pattern, they have removed the third element, which is 2. Okay. So this element is been removed. So you can either remove this also, yes or no. If you remove this, then your pattern will be just directly this, and then up, up, down, and down. Okay. So this is the longest zigzag pattern you can have. You cannot take this element at zigzag pattern in the zigzag pattern. Okay. Now they are deleting that particular third element, which means your pattern will look like down, down, up directly to the 3, then down, then down. Okay. Still, this time the maximum pattern comes out to be not this, okay, but it comes out to be this. From starting from here, you go and up. So it is down. Use another pen. So it is down, up, and down. Okay, so the total points here are 4. That's why the answer is 4. Okay. Now, if you delete this element, the next element will become your peak, or the next element will become your valley. Okay, either it will become peak and valley. Now, if this ith element was deleted, the comparison will be between I minus 1 and I plus 1th element. Okay, so the comparison will be between I minus 1 and I plus 1 element. Now, check if I minus 1th element is smaller than I plus 1th element. So this is up down condition, and which prefix was storing up down condition? My prefix 1 was storing up down condition. So what I will do, I will take prefix 1 plus suffix 1. Correct? Now, if this was a valley, if this became if I plus 1 was a valley, so I plus 1 will be less than I minus 1 at this time. Now it will be a down up condition, and down up condition will be stored by prefix 2 plus suffix 2. So as I've told you, if you delete a particular element from this array, the remaining part will be concatenated. So this part is prefix, this part is suffix. Just add both of them, then you can get your answer. So that's why I'm adding prefix 1 with suffix 1, prefix 2 with suffix 2, because it was up and down condition and down and up condition. Alright. I hope now you understand the logic. Okay, is this clear now? Okay, try with all, make four vectors, prefix 1, prefix 2, suffix 1, suffix 2. It's easy. I've made a 2D vector, that's why it's look confusing. But here 2D vector just 0 denotes prefix 1 and 1 denotes prefix 2. Okay, so for 0, I have done, I have taken the addition of prefix 2. Okay, so prefix 1 is equals to prefix 2 plus 1, prefix 1 is equals to prefix 2 plus 1, and here prefix 2 is equals to prefix 1 plus 1. Now just take an answer for all the prefixes possible. So you are going iterating all the prefixes. It's the basic answer without deleting an element. Starting answer without deleting an element. Now make a suffix vector in the same manner. Your suffix 1 is equals to suffix 2 plus 1, and suffix 2 will be is equals to your suffix 1 plus 1. Okay. Now same thing again. Take all the maximum of all the suffix without deleting an element. All right. Now after that you are deleting an element. That's why I'm iterating from 1 to n minus 1, because deleting a last element and the first element is similar to deleting similar to taking prefix of n minus 1 and suffix of 1. Okay, so that's why I'm not iterating from 0 to n. Now if you have a up down pattern, okay, as you can see, if it's a up down pattern, so prefix 1 was storing up down pattern, so take sum of prefix 1 plus suffix 1. This is I minus 1 because I have deleted ith element, and this is I plus 1 again because I deleted the ith element. If it is down up pattern, so prefix I minus 1 is less than prefix I plus 1, so you just take the prefix 2 plus prefix suffix 2. Okay, now it is understood. I hope now it is very clear, like I have gone into very depth of this problem. I hope this is clear now. Okay, so this was all the four problems, and that's all from my side. I hope you have enjoyed this live session today, and hope you were able to solve all the problems now. And if you really like this video, please consider subscribing, and uh, the membership on the channel is also available. You can just go and check that out also. Thank you for joining with me today, and we will meet again in the next contest. Uh, Thank you and have a good day ahead. Bye bye.